In the previous video, I ran LTX 2.3 after modifying the default workflow from comfyUI templates. These nodes were removed, and this second stage was deactivated. This section, which is stage 1, was only used to generate the video because running both on a smaller system caused problems. The problem has now been fixed, and we can run the second stage as well. The red-colored nodes were added, and links to download the models are provided around them. Now it looks better. Here, I tried the NAG nodes for LTX, but the difference looked minimal. To use the GGUF models, we need to replace these two nodes. Double-click and search for UNet and add this UNet loader. This will replace the diffusion model node. Now search for clip loader, and there are two of them. Which one should I connect between these two nodes? In the manager, under the installed nodes, I will search for GGUF. If you do not have these nodes, then you have to install the node group first. Apply the filter, select all, and search the node group, then click the install button similar to this. So this node group is written in uppercase letters by City96. Open the project, and we can see it has 3.4K stars. Similarly, the other also has stars and the last release date. So you can go with a more popular one. Make sure to install this node, restart comfyUI to have it in your workflow. I realize that this clip loader takes two files. So I will search for the dual clip loader. Links to download the files are added around the nodes. Similar to this load diffusion node, you will have to connect this node, and that is it. I am using the distilled Q4KM GGUF file, and the direct download link to the file is given above. Below are the links to other GGUF files of different sizes. This link has the dev.ud version of the file, and also the distilled files. Here, I made a mistake. Both dev and the distilled files are available by a different user named QuantStack. Click to open, and you should see the files uploaded by Unsloth. The dev version is in front of us, which also includes UD models. The D here stands for dynamic weights, uploaded 10 hours ago. The letter U, I think, stands for the user, which is Unsloth. As far as I understand, the diffusion model with dynamic weights can change the weight based on the resource availability, and then it should produce the best possible result on the system. Please add your inputs and comments if you have a better understanding on this topic. In the above folder, we have the distilled file, and I noticed the UD model just now. So I have mentioned the sampling steps and the CFG required for both of these models. You will get a bad result if you ignore this. After downloading the file, press the letter R to refresh and select the GGUF file. Similarly, you need to download the Gemma 3 file. This is the direct download link to the file I am using. Any other file, smaller or larger in size, from the one I am using, can be downloaded from the given link. Place both the files in the text encoder folder, and then select it here. Make sure the type selected here is LTX. Make the connection, and you are good to go. The audio and video VAE were downloaded and selected in the last video, so it is as it was. These are the old prompts from the previous video. Now I have added a few new prompts with a prompt guide. You can go through this prompt guide, which should help you write prompts. Or else you can give everything to GPT and ask it to give a prompt based on the given guide. But be aware, GPT is acting dumb, and the prompt given to me did not follow the guide. I have given the guide here, if you want to copy and paste it somewhere. So I will connect one of the prompts, and the prompt is about a man standing on a tall rooftop. Dense modern skyline, and the wind blows. I have downloaded the smallest Q2 GGUF model. I will try this to see how it goes. And I am using the distilled model, so I will keep the CFG and sampling steps low as mentioned around the download links. The video length is 241 frames, which is 10 seconds in length at 24 frames a second. Make sure all the frame numbers match. And then run the workflow. One step takes around 10 seconds, and everything took 137 seconds on my 4060 Ti 16 GB. The result looks bad. This can be improved to some extent if we run the second stage in this workflow. We will see a comparison ahead. Let's try the Q4 model and see how clear things become. The Q4 was done in 120 seconds. This is clear and has more details, but with a disfigured jacket, which was supposed to be flapping due to strong winds. I am downloading the Q4 KMUD model to see the difference by dynamic weights. Press the letter R to refresh the file list. Select the UD model and run the workflow. The time taken was 107 seconds. No signs of wind blowing and some weird movement. I will select the FP8 model to see how well it gives the result. It took 158 seconds, and this is the result. I've added a few more prompts based on timestamps. The scene is about a young scientist in a lab, and in the first 4 seconds, he should adjust his glass and look into the camera. Then in the next 4 seconds, the character speaks and below is the dialogue. And then some other activities at the end of the 10-second clip. Similarly, there are a few more you can try. I will connect one of the prompts, and the model selected is the FP8 file. It took 153 seconds. So let's check the result. The character should close the laptop and move forward. Then he should start speaking.
I just finished editing the new tutorial video.
There is no lip movement happening, but it should work. I will try the UDQ4 model. It took 250 seconds. The time taken was longer due to the change in the diffusion model.
I just finished editing the new tutorial video.
Still, no proper lip movement is happening. I tried a different prompt, and there is a slight improvement in lip sync with the dialogue.
Mission update. Everything is running perfectly.
Tonight's headline: technology just moved another step forward.
This might be the smartest gadget released this year.
So that was text-to-video generation with stage 1 processing. Now let's look at the image-to-video with a GGUF model and the second stage processing, which should improve the result. I will copy and paste the nodes added. And these are the few prompts generated by GPT. Upload the image, 241 frames for 10 seconds, and make sure the number of frames per second is 24 in all places. Connect the prompt and run the workflow. It took 116 seconds, and this is the result.
Where is my cape?
This was my mistake because I did not verify the response given by GPT. I should be using the Quinn text model or Gemini. The video prompt had broken robots, a superhero suit, and a cluttered headquarter. So I used the Flux Clean model to generate an image. And then I used the Quinn model because the character here is supposed to run and look for her red-colored cape in the drawers. And while doing so, she makes a mess. Later, she finds the cape and then laughs.
Where is my cape?
The unclear edges you see can be fixed in the second stage of the workflow with the latent upscale model. Make sure you have the upscale model in the latent upscale folder and not in the LoRa folder. 3 steps of iteration took 178 seconds. Paragraph prompt gives a bad result most of the time. You should try timestamp prompt. I will try the Q4 model, and this is the image generated using the FluxClean model. I will be using the timestamp prompt with some activity. This prompt was made in reference to this superhero versus a tiny villain. Connect the prompt and run the workflow. I got the first result after the first stage of processing. I will now process the same in the second stage. The result in the second stage you can see. I tried a few minutes ago.
Rulers! One of it is a fancy of 5! That one is a crack! No way!
But this was a mistake from GPT.
Figaro fair! Huh?
The result is not perfect, but I will share this so you can drag and drop on comfyUI and get the exact settings and prompt to begin with. Let's add an audio file in the image to video workflow. So I have generated this tomato using the Flux model. This is the prompt, and the image has been uploaded here. And this is the section that deals with input audio. The output from this node group is connected in the LTX workflow. This is the empty latent audio. When this is connected, the audio generated will be from the LTX model. And if this is connected, we need to upload an audio file here, which should be used while generating the video. This trim audio duration is in red color because it is important. You need to match the duration with the length of the video. The duration is 20 seconds because the video length is 441 frames. That will be a 20-second clip at 24 frames per second. Make sure you keep the number of frames matching. This Set OG Audio node takes the audio and uses it in the Create Video node. The Video Decode node will be connected all the time. It doesn't matter where the audio is coming from. This latent audio is coming from the LTX model, so if you want the audio from LTX, then have this connected. Or else if you are uploading your audio file, then connect this ORG, which is the original audio. To generate a proper lip sync, you should only let the clear vocal enter the LTX workflow. You can have the instrument as well, depending on the kind of video you are generating. In this use case, I need the vocals only because I want the tomato to speak. But the audio file I have uploaded does not have any instruments or background sound. So I am not using this node, which is using the model to separate the vocals and instruments. The link to download this model will be given in the workflow. So, based on the vocals and the audio, a result is generated. Let's check.
They told me I have to save the world. The whole world. I'm this big. I have one pocket. One. But it's a good pocket. And I am going to save this world.
The edges are less accurate, but the lip sync is good. The second stage of processing the video will fix those problems.
They told me I have to save the world. The whole world. I'm this big. I have one pocket. One. But it's a good pocket. And I am going to save this world.
You should avoid generating fast motion, but the lip sync works fine. I have used some WAN workflows that were better, but LTX is fast. I will make the workflow as it was before with the connections. Get the workflow from the description, where you can drag and drop the result on comfyUI to have the workflow. So that was it in this video. I hope the video was interesting or informative, and I wish you an excellent day.